Hi students, now we are going to learn the topic namely fluid pressure. Any substance which has a capacity to flow is called a fluid. There are two types of fluids, namely liquids and gases. In the previous topic we studied the pressure exerted by applying a force on a drawing board pin on solids. Now we are going to discuss about how the liquids exert a pressure. Now the first one, you take some water in a beaker. Okay? If you pour some water in a beaker or a glass tumbler, do you feel it heavy or not? Why do you feel heavy? Because water is having some weight. Weight is nothing but a type of force called gravitational force acting on the water, and the entire weight of the water is now kept on the bottom of this glass, bottom of the glass. So in this beaker, now the entire weight is acting in the downward direction. You can see that the total weight of the water is acting on the bottom surface area. So let the area of the bottom of this beaker be capital A, and W is the weight. W is the weight of the water. Now weight is nothing but the gravitational force. Okay, and this is equal to what? Mass into acceleration due to gravity. Understand? Mass into acceleration due to gravity. Therefore, how much pressure this liquid is exerting on the bottom surface of the beaker? Pressure is equal to this gravitational force divided by area. Force per unit area is called as pressure. Is it not? Now, instead of this force, I can substitute what? M into G divided by the area A. Now, what is the density of any liquid? Water is having a density, is it not? Water is having a density. Okay, the density of water is rho equal to 1000 kilogram per meter cube. 1000 kilogram per meter cube. So water is having a density. So rho is the symbol for density. Density means what? Mass by volume. Mass by volume. So rho equal to what? Rho equal to mass by volume, or volume into density is equal to mass. Volume into density is also equal to mass. So instead of this mass, I am going to substitute volume into density. Therefore, now pressure is equal to what? Volume into density of water into acceleration due to gravity divided by area. Suppose if the height of water, the level of water inside the vessel is equal to h. So how will you find that cylindrical volume? Suppose if this is a cylindrical vessel, means that the volume is also cylindrical in shape. So how will you find the volume of the cylinder is equal to this height into base area, bottom area into height. So in place of this volume, I can substitute volume. This is also equal to base area into height. So area into height is equal to what? Volume. Remaining two factors is what? Rho into G and divided by the area. Can you see that the area term is getting cancelled? Therefore, the liquid pressure is given by the expression H into rho into G. Pascal is the unit. H into rho into G. Okay, this pressure exerted by the liquid or any fluid is given by the same expression only, H rho into G. Now, the air present in the atmosphere, the air is surrounding us, air has weight. With a balloon experiment, you must have studied in the lower classes and proved that air is also having some weight. Now, does the air present in the atmosphere exert some pressure on all of us or not? Yes, sir. That is called as what? Atmospheric pressure. So, what is the atmospheric pressure we are going to discuss now? So, what is meant by atmospheric pressure? It is the pressure exerted by. So, this is nothing but the pressure exerted by the air. The pressure exerted by the air in the atmosphere. The air will exert pressure in all the directions, upward direction, downward direction, left, right, side, everywhere. In all the directions, the air will exert the pressure. So sometimes when you go on when you climb some hill stations, high altitudes and all, you feel very tough to breathe. Is it not? Why? Because the atmospheric pressure will be very less. Air pressure will be very less outside. Your blood pressure will be greater than the air pressure. So the difficulty in breathing will take place. Understand? Sometimes in jet aircraft and all, the passengers will keep some cotton inside the nose and the ear also to bear the changes in the atmospheric pressure. So you must remember that the air also exerts pressure. Already we have studied here, water exerts pressure, is it not? So if you go to the bottom of the swimming pool, means you will feel very heavy, understand? Why? The entire water is exerting a pressure on you. So the pressure will be maximum at the bottom of the swimming pool. That is called liquid pressure. Like that, the air also exerts pressure, that is called as atmospheric pressure. And it can be measured by an instrument which is called as barometer. So barometer is an instrument which is used to measure the atmospheric pressure. Now in all the mathematical calculations in physics and chemistry, the atmospheric pressure at sea level is taken to be P is equal to 1.01 into 10 to the power of 5 Pascal. This is the standard value of atmospheric pressure exerted by the air at sea level. Okay, the first barometer model was constructed by a person, namely Torricelli. Torricelli is the name of the person who constructed the barometer. So for this he took a vessel, large vessel called a trough, filled with mercury. So the liquid taken by him inside this container was mercury. Mercury is a very heavy liquid, do you know? It is a liquid metal, silver, white in color, understand? Silver color. Now he took two different sized tubes, vertical tubes, and he filled mercury inside this also. Hg is a symbol for mercury. Hg is the chemical symbol for mercury. So in the two tubes he took mercury and he inverted, by closing the mouth, he inverted the two tubes and inserted inside the large trough containing mercury. So you take two vertical tubes, fill mercury in them and close their mouth with your thumb, and then invert the tubes and insert inside the large trough containing mercury. After some time, the level of mercury inside the two tubes will get adjusted and it will rise from this actual level. From this actual level of mercury, it will rise to a height of 76 centimeter. 76 centimeter height. Whether the tube is tilted or kept straight, or whether the tube is broad or very narrow, in both the cases, the height of mercury will be only 76 centimeter. It is a constant on the surface of the earth. Why this mercury is rising inside the tube? It is because of the pressure exerted by the air. The pressure exerted by the air in the downward direction. I told you that the air will exert pressure in all the directions. Is it not? So in this, the air is exerting the pressure in the downward direction, and the pressure is given by what? H rho into G. Here height is equal to, here the height is equal to 76 centimeter of mercury. So what is the atmospheric pressure value? If they ask, means it is 1 atmosphere. So this value only is called as 1 atmosphere. 1 atmosphere is also equal to 1.01 into 10 power 5 pascals. So my dear students, you should know that the air exerts a pressure in all the directions, upward, downward, sideward, like that. Now I will take this container filled with water. Can you see some water spilling out? Okay. So I have taken some water, leaving some gap. I will take a cardboard paper and I will just close its mouth. Okay. And I will insert this container. Can you see that the pressure of the air is acting upward on the cardboard, so that it is balanced by the weight of the liquid inside the container. So the air exerts pressure in the upward direction also. So this is a demonstration to understand that the air exerts pressure in all the directions. So you must remember that fluid pressure means it is a pressure exerted by both the liquids as well as gases. Understand? By the liquids as well as gases. So the liquid exerts pressure at the bottom of the container. Always at the bottom of the container only the pressure will be greater. This is why it is very difficult to swim at the bottom of the swimming pool and easy to swim on the surface. On the surface the pressure is comparatively lesser. Is it not? So this is liquid pressure and it is given by the weight of the liquid divided by the area on which the liquid is acting. So the general expression to calculate whether the liquid pressure or the air pressure is what? H rho G. Understand? And Torricelli was the first person to construct an instrument to measure the atmospheric pressure, and the name of the instrument is called as barometer. Okay? And the value of the atmospheric pressure, standard value is 1 atmosphere or 1.01 into 10 power 5 Pascal. I hope you must have understood well. Fine.